Let's understand a few important things about the Gordon model. The Gordon model says that the price of a stock right now is equal to the next dividend divided by Ks minus G, the required rate of return on the stock minus the growth rate. Okay. Pay attention that the dividends will always start one period after the valuation. So if, for example, you need to evaluate the price of the stock in year number 4, you can write that this is equal to D5 divided by Ks minus G. The required rate of return on the stock is stable, will stay the same. The growth rate is constant and forever, so it will stay the same. All we need is just to change the notation that the dividends will start one period or 1 year after the valuation period. Okay, that's the first thing. The second thing I want to see is that whether I lost information on the way. We first started with the concept that the company is a going concern, which means that it will last forever and it will generate dividends forever. But here I see only the next dividend, D1. So what happened to all the other dividends? Where are they? Am I losing some information on the way to develop the Gordon model? And the answer is no. I have here stored inside this compact formula all the information about all the next dividends. Why? Because I have G, the growth rate. Once I know any dividend and I know the constant growth rate, this is the mechanism that links all the dividends one to another. Therefore, I didn't lose any information on the way to develop the Gordon model. Using both D1 and G, I can predict what will be D2, D3, D4, and so on forever. That's also a very important thing to understand. One final thing about the Gordon model is a general limitation of the model. And here I'm excluding, obviously, the fact that G is assumed to be constant and forever, and we already understand that this is a major limitation because companies do not grow forever and definitely not at the same constant growth rate. But in addition to that, there is one problem with this model. The problem is when G exceeds Ks. Let's understand that. Dividends, they have to be positive. Whenever you buy a stock, the company can only pay you dividends. They cannot charge you by some cash flows because you purchased their stocks. They cannot punish you for purchasing their stocks. They can only pay you dividends. So dividends must be positive. The problem is, let's have a company that is growing very, very fast, that G is very high, but Ks, the required rate of return on the stock, is too small. If G, the growth rate, is too big and Ks is too small, G will be higher than Ks. In this case, the denominator will become negative. Well, developing positive number by a negative number, you will end up with a negative price, which is obviously nonsense. It doesn't make any sense. What do we do in this case? Pretty simple. We don't use the Gordon model. So if you have a situation where the company is growing very, very fast, for example, a startup, and on top of that, the required rate of return is not that high, in fact, it is lower than the growth rate, we will simply ditch the Gordon model. We will use other things. So that's a major limitation that you need to be aware of. Altogether, if G is bigger than Ks, the Gordon model leads to a negative stock price, which doesn't make any sense. The Gordon model can only be used if Ks is bigger than G. Only then you will get a positive denominator. And G, just remember, it is expected to be constant, fixed, and forever. How can we find the required rate of return on the stock? Very simple, we're using the security market line. We already did that several times in the past. Let's see an example. If you know that the risk-free interest rate that we usually measure it from treasury bonds is 7% per year, the market return is 12%, and beta of a stock is 1.2. That's an aggressive stock. Remember, beta bigger than 1. In this case, the required rate of return on the stock, Ks, using the security market line is equal to the risk-free interest rate plus the market risk premium times beta, which is 7% plus the gap between 12% and 70%, market return minus risk-free percent, it means 5% market risk premium times 1.2. So 5 times 1.2 is 6% plus 7 altogether 13%. In the following examples, we will use KS as 13%. This is the appropriate discount rate for stocks, for equity. And the same thing that we used the yield to maturity to represent the appropriate discount rates for bonds. One thing I will say also about this is that when we use the SML, the security market line, the required rate of return on the stock, over there we wrote it as RI, return on a stock. Over here it is written as KS, but for any purpose it's exactly the same thing. What is required by investors, it is the returns from the shareholders. So KS here and RI over there, when we spoke about the SML, it's exactly the same thing. Let's see a snapshot over what happens for the first 3 years just to understand the process. Let's say that you observe a company that pays a dividend, current dividend of $2. So this is observable. This is what you see because you just saw it a second ago. And the growth rate is assumed to be fixed at 6% forever. Let's find the expected dividends for the next 3 years and their present values. If you start from the dividend right now, the current dividend is $2. Remember that this is your starting point. This is your observable thing. Everything else is predicted. Into the future is predicted. Nothing is guaranteed. You draw the timeline from 0 to 3. Based on the first dividend, in order to understand or predict what will be the next dividend in year number 1, D1, we multiply D0 times 1 plus G. So do $2 times 1.06, you will get D1 equal to 2.12. Take D1 times 1.06, you will get that D2, the dividends in year number 2, will be $2.247. Take D2 times 1.06, 1 plus the growth rate, you will get D3, the dividends in year number 3. Based on that, you receive a dividends in year number 3 of $2.382. Notice that we're using the growth rate to generate future dividends, to predict future dividends. Now we need to discount them to present time. The way to discount them is to divide by 1 plus the discount rate, the required rate of return on the stock, which is 13% in our example, to the power of the number of years. So take D1, 2.12, divided by 1.13, to the power of 1 if you want, you will get $1.8761. Take D2, which is $2.247, divide it by 1.13 square, you will get the present value of the second dividend, which is 1.7599. Take also D3, the dividend in year number 3, 2.382, discount it to present time, which means divided by 1 plus KS to the power of 3, 1.13 to the power of 3, and you will get 1.6509. This is the process that essentially we're doing. We're first generating future dividends, predicting what will be the future dividends based on the growth rates, and then we discount all of them to present time based on the required rate of return on the stock. At the end, we will summarize all of these, and this will serve for us as the present value of future cash flow, which is the price of the stock. I will say now and I will say it again later. When we sum up all the present value of future cash flow, we exclude, I repeat, we exclude the current dividend. D0 is just your starting point because it's the only thing for sure, the only thing that you know for sure because it is observed. So based on D0, you can predict D1, D2, D3, and so on. But eventually, when we will summarize all the present value of future cash flows, only future. It's not present and future. No, it's the present value of only the future cash flows. We will exclude D0. I emphasize this point because over the years I saw many students that making the mistakes, they see this number here along with all the other numbers and they simply add it too. Wrong. Do not add it. D0 is only served to first generate the future dividends, discount them after that, but when you summarize all the present value of future cash flows, you should exclude, take out the D0. Let's use the Gordon model based on those numbers. P0 is equal to D1 divided by KS minus G. This is the Gordon model. Let's plug in the numbers. D1, $2.12. Here it is, $2.12. D1. Divided by KS, 13% minus the growth rate of 6%. Do the numbers and you will see that price of the stock right now is $30.29. In other words, in this slide, what you saw is just a snapshot, just a zoom in into the first 3 years. But if you will keep on adding those numbers all along the years, all the way into the future, never stops, it's a going concern, this will be the present value. Price is equal to $30.29. What is the expected market price of the stock 1 year from now? Well, in this case, we need to calculate P1. Based on the Gordon model, P1 is equal to D2 divided by KS minus G. Just remember that the dividends will always start 1 period or 1 year after the current valuation. If you need to price P6, you will start with D7. P18, you will start with D19. Let's plug in the numbers. D2 is equal to $2.247. Here it is, $2.247. That's D2, the dividends generated in year number 2. Divided by the same KS minus the same G, 13% minus 6%. Do the math, and you will see that P1 is equal to $32.10. Does it make any sense? Yes, absolutely. P1, in fact, is P0 times 1 plus the growth rate. You can check for yourself. If you will do P0, which is equal to $30.29, times 1.06, 1 plus the growth rate, you will end up with $32.10, which is exactly equal to P1, the price of the stock 1 year from today. Remember that the Gordon model says that G is the growth rate for the entire company, for the earnings, for the dividends, and also for the stock. What it means is that there is a stock price appreciation here. By how much? By the same growth rate of 6%. Right now, the stock is evaluated at $30.29. A year from now, the stock should go up and become $32.10, and that's because it is a stock price appreciation of 6%, the growth rate G. So let's understand what happened here. What is the expected dividend yield, capital gains yield, and total return over the first year? Let's say that you purchased the stock at the current stock price valuation of $30.29. 1 year from today, you will sell it at a higher price of P1, $32.10. In addition to the stock price appreciation, you also receive the first dividend in the first year. The first dividend are assumed to be $2.12. So let's see what is your total return. Notice that you have 2 sources of income in the first year. The first source of income is the dividend yield. Dividend yield is the return from receiving the dividend. It is defined as how much you get relative to how much you pay. How much you get from dividends is D1. That's the only dividend that you receive in the first year, which is $2.12. How much you paid is P0, which is $30.29. Dividing this by that, you will end up with a dividend yield of 7%. In addition to that, you also receive the capital gains yield, in other words, the stock price appreciation. This is the how much you sold minus how much you bought divided by how much you bought. PT minus PT minus 1 divided by PT minus 1. Remember, that's our definition for a return. How much you get dollar amount in the numerator divided by the denominator, that's a percentage return. So stock price appreciation or capital gains yield is P1 minus P0 divided by P0, that's a 6% return. So take a look what happened here. On one hand, you receive 7% dividend yield. On the other hand, you also receive capital gains yield of 6%. Both of them together will give you your total return of 13%, which is, surprise, surprise, equal to KS, the required rate of return on the stock. Altogether, we can see that as long as G is constant, your total return is equal to KS. This is what you require and this is what you get. Your capital gains yield is equal to G. This is the growth rate for the entire company, for the earnings, for the dividends, and also for a single stock, which means stock price appreciation. This is G. And dividend yield is the complement to G, which means this 7% is in fact KS minus G. Whatever you don't get here, because you require that as KS, you will get it here from the dividends. So please write to yourself, right next to this 7%, this is equal to KS minus G. Right next to this 6%, this is equal to G. And right next to this, this is equal to KS. This is true as long as G is constant. We will see a couple of examples when G is not constant, and over there you will see that this case does not hold. What will be the expected price today if G is equal to 0? So first of all, let's look at the Gordon model, see if we can plug in G is equal to 0. The Gordon model says P0 is equal to D1 divided by KS minus G. In this case, if G is 0, we can simply eliminate it from the denominator. What you're left is D1 divided by KS. But when G is 0, what it means is that the company is not growing. Notice that not growing doesn't mean dying. Not growing means stagnation. They keep on earning money, but at the same pace. They keep on paying dividends, but at the same pace. That's about it. So if the dividends are not growing, D1 is equal to D0, and it's also equal to D2, D3, D4, and so on forever. This is what it means, G is equal to 0. So in the numerator, you have fixed payments divided by the required rate of return on the stock. This should remind you the formula for the present value of a perpetuity. Perpetuity, we defined it as equal cash flows, equal payments, starting from the next period for unlimited lifetime, forever. This is what happens here. D1 will be fixed forever. All the dividends are fixed with 0 growth divided by the discount rate. This is exactly the formula for the present value of a perpetuity. So if G is assumed to be 0, what you have here that D1 is equal to D2 is equal to D3 and so on forever, this is exactly a perpetuity. Price of a stock right now is equal to equal payments, equal dividends divided by KS, which is $2 divided by 13% KS, required rate of return on the stock, which gives you $15.38. First of all, does it make sense? And the answer is yes, it makes sense. Look, if the company is growing at a 6% growth rate, the price of the stock right now is expected to be $30.29. Well, if the company is not growing, 0 growth rate, the stock price is cut by half, roughly, over here. But that's okay. The company is not growing, so you should take a discount. The stock price should be much, much lower than for a company that is growing. Let's try to value a common stock with non-constant growth. Let's start to deal with more complex situations. What happens if you have two different cycles? You have first a cycle for a couple of years with a very fast growing, and after that the growth will slow down. You can think about the following scenario. You have a company that is growing very, very fast in the next 3 years, perhaps because it is acquiring more and more market share, perhaps because the economy is growing very fast right now. So in the first 3 years, we expect this company to grow for 30% per year. After that, the growth will slow down, become 6% from this point on forever. With the same KS as before of 13%, and let's start with the same dividend as before, $2. That D0 is your only observable dividend. Let's see how to deal with such a case of non-constant growth rate. Using the growth rates, we need to predict the future dividends first. So D1, $2.60 is equal to D0 times 1.3. D2, 3.38 is equal to D1, 2.60 times 1 plus the growth rate 1.3. D3, $4.394 is equal to D2, $3.38 times 1.3. After that, we're switching to a different growth rate of 6%, and therefore D4, which is $4.658, is equal to D3, 4.394 times 1.06. And that's about it. We don't need to continue after that, because after that the growth rate becomes stable. It's fixed, so we can apply the Gordon model from this point on. Please notice that we cannot, I repeat, we cannot use the Gordon model all the way right from the beginning. Why? Because we have two different growth rates. You have 30% for the first 3 years and 6% then after. The Gordon model works only when G is constant. And G is constant here only after the third dividend, fourth dividend, and so on. So we're going to apply the Gordon model only from this point on. We cannot, I repeat, we cannot use it all the way from the beginning. All right. Once we generated the first 4 dividends, which should be enough for our purpose, let's discount everything to present time. Let's start from the end. P3 is equal to D4 divided by KS minus G. Notice that I'm writing D4, this is where I stopped, so I need to calculate P3, the price of the stock in year number 3. You need to write it correctly, and you also need to place it correctly under year number 3. This will help you to understand that P3 is the valuation of all the future dividends that include D4, D5, D6, and so on forever. So P3 is equal to D4 divided by KS minus G. We know that KS is 13%, and G, now that it is constant, we can use it. It is 6%. So P3 is equal to 66.54. But then we need to still discount everything to present time. So D1, let's discount it to present time. Take $2.60 divided by 1 plus KS, 1.13. You will get 2.301. Take D2, 3.38. Discount it to present time, or divide it by 1 plus KS squared. So 3.38 divided by 1.13 square is equal to $2.647. Take D3, divide by 1 plus KS to the power of 3, and also take P3, which is located here. P3, $66.54. Discount it to present time, in other words, divide it by 1.13 to the power of 3, because it is located here at year number 3, and you will get 46.114. Eventually, what you need to sum is everything excluding D0. I repeat, you do not include D0 in your calculations here. You started from this point because that's the only observable number that you know, for sure. But at the end, you end up by summing all the present value of future cash flows, only future cash flows. It's not present and future, only future cash flows. So you need to add 2.301 plus 2.647 plus 3.045 plus 46.114, and you will get roughly $54.11. That's the current valuation of the stock based on present value of future cash flows.